Hello, everyone, and welcome to Handmade Hero Show, where we code a complete game live on stream. Before we get started today, I just want to take a minute to thank our sponsor, the Rust Recovery Foundation. This is a great organization. If you haven't heard of it, they're just a collection of really kind-hearted programmers who work with people out there who are really into Rust and have found out in one way or another that there are programmers out there in the world not using Rust. And that can be really hard psychologically on people. There are some people who never come back from it. And so this organization is just a great, it's just a great way to help support those programmers and try to let them get readjusted and reintegrated into programming again after what can be, it can be a really big shock to the system. And so, check that out if you get a chance. The Rust Recovery Foundation, they do great work, and they help literally dozens of Rust programmers every day sort of overcome that world-crushing realization that not everyone in the world loves Rust as much as they do. So it can be very hard, and I just, if you have some empathy for that kind of position, I highly recommend checking it out. Do give generously. Let's go ahead and get started today. We have, I think, more or less finished what we wanted to do on the collision detector. Essentially what we wanted here was we just wanted to make something, I gotta adjust my monitor, that I would have some confidence that wouldn't crap out on us. I didn't want like a very brittle collision detector. I wanted something that would be fairly stable. And so what I did is I made something that does sort of a voxelized sort of collision system with some fairly straightforward rules about how you can move through the space. And I think it's pretty good. We didn't try to do any formal proofs on it or anything. Not that anyone ever does that besides me for their collision systems. But, we could go that route if we wanted to really get into it. But we don't really, not for this game. But, you can see here I've got the glove on full collision. So we're just checking to see, it can't really go through things. If it does get stuck in things, because like that where I push a object that has to be moved, like the gameplay is moving an object into an object that cannot itself be moved, you can see it generally finds places to put things. If it does embed something, like here where it can't find a place to put something and it has to embed it, like it does there, it is capable of moving things out of embedding. So I think we're in pretty good shape as far as collision is concerned. I don't have a lot of concerns about the system right now. So what I'd like to do today is move more into just the cleanup phase for the collision detector. The things that I wanted to do was add a spatial partition. So, I'd like to have a thing where I'd like to do something where we can not test all the entities every time. Right, we've got a kind of ridiculous system right now that actually checks all of the entities in the entire world, and excuse me, and that's really not in the entire world, in the entire active set. So the entire, everything that's paged in here, right? All of these entities are getting checked for collisions every time, which is completely ridiculous, if that makes sense. And so we more or less know that we have to have a spatial partition at some point. It's already much slower than it should be. It just so happens that computers are so darn fast these days that the game still appears to play in real time. But that's only because computers are so incredibly fast, and we just haven't dumped enough entities in. Like, if we doubled the number of entities, I think we could get it to start slowing down, certainly. If you look, I don't remember what the profiler is here. If you look, you can see this is starting to creep up in time here. And remember, this compute light propagation is multi-threaded. So actually this percentage time is how many cycles it's taking. It's not really representative, however, of just how expensive this is, because this is only running on one CPU. So it's taking that many, one core. It's taking that many cycles without even being multi-threaded, right? So it's an issue, right? It's an issue. And so as you dump more in there, that n squared will just keep rising. It'll get worse and worse. So that's why you really want a spatial partition, because we don't really want to see this on our... It should be mostly free. Like, collision detection here is not that complicated if you just don't test too many entities. So we really just kind of want to simplify that down, right? We want to make sure that we don't have that creeping up there. All right, so those are two things we want to do to get us into good shape here. So what I'll probably do before I do the spatial partition is start by adding a spherical collision type so that we can have spheres and boxes. The reason I want that is just to make it a bit smoother. So, like, for example, this guy here, right? You can see, like, this dude here is... I feel like that... I wonder if that should happen. Like, I don't know how these guys, like, work exactly, but I feel like they shouldn't embed in the ground like that. But maybe they should. I don't really know. We should take a look at that, because I don't feel like they should do that. Unless... I don't really remember how we move them, to be completely honest with you. So I don't actually know if that's true. But we should probably look at that. It doesn't get stuck because it allows him to move, but it's not really supposed to be doing that, right? So that's something we should probably take a look at. But what I was going to say is, any of these people who move around, like this dude or the glove, they should be spheres, because we don't actually want them getting stuck on corners, right? We don't want them to have, like, that, right? I need a thing to, like, turn off above layers of collision there. Above layers of floors. We don't want them to get stuck. I guess that wasn't a stuck. Well, that, right? We want them to be able to roll off of corners, and they're not going to, right? Now, the thing that I was saying is, like, this guy isn't stuck there per se, but it does seem like he's allowed to interpenetrate maybe more than he should be able to. This is a better... Okay, that's a better example. So, do you see how he's on that? So I'd like things to have a rounded appearance, a rounded collision volume, so that they roll off of things more cleanly. And so if you have two flat faces and they hit each other, right, it's not going to be... the collision normal is not going to be such that it can move cleanly around it. It's just going to run in and stop. Whereas if you have a... excuse me... a sphere, it can always move sort of diagonally around and keep going, which is kind of more what we want, right? So I'd like to have a sphere collision volume and allow both spheres and cubes. And then the other thing is, I'm not confident that I don't understand what that embedding... I don't understand what's actually going on there, because I didn't think we allowed that. It's a little hard to tell. Maybe it's not actually embedded, but it sort of looks like it is, right? It's slightly embedded, right? And so the main thing I'm just concerned about is, why did that happen, right? Do we have a bug that makes it so that you get slightly embedded like that? And I don't really know, right? So I'd like to take a look at that as well, just so I can have some understanding of what's going on. But I would also like to add the spheres in here. And we'll leave that guy as... we won't actually replace him with a sphere. I'm going to replace the glove with a sphere first, and that's what we'll do today. And then we'll take a look at... and then we'll take a look at what's going on with that. Okay, so if I go to move entity, which is in here, then what you can see is essentially this routine where we look to see what happens with a particular collider. This routine would need to understand the difference. So this routine would need to understand the difference between a sphere and a rectangle, right? So this would need multiple routines. It would need sphere versus sphere, sphere versus rectangle, and rectangle versus rectangle. We already have one of them, which is rectangle versus rectangle. But we don't actually know, we don't actually have a way to set one of these collision volumes to be a sphere yet, right? So we need a way of putting that in there. We also don't, I mean, one thing that's a little annoying is we don't have a way of rendering a sphere. Our renderer just renders sprites. So it's a little bit difficult for us to render a sphere in the first place, which is unfortunate. If this were a general purpose renderer, rendering a sphere is easy. In our case, we just don't have, we've never built any rendering capacity for things like spheres because we don't really render any 3D geometry other than just a cube, right? So if we look at this, it's going to be something more, a little bit different. So, if you take a look at how this goes, where we've got this replaced with spatial partition thing. So this thing where we're iterating over the entities, that's going to iterate over the entities within a particular spatial partition bucket or something like that. And then what's going to happen in here when we do this test is we're just going to have 3 different tests we can do, right? So we're going to have probably something that looks like this. Where we just check and we say, is this entity right? Something like that. So like in here where we do where we look to see what kind of collision we're talking about, we just say like, all right, we are going to have a flag that tells us whether an entity is used as spherical or rectangular collision. And what we'll then do is say, all right, when we do a sphere collision, we loop over and we just need to do a check either way. And then the same would be true for our other branch here. And again, this has to get replaced with something better at some point, but that's fine. So then in here, what we need to do is we need to pick 2 different things. So if there's a sphere collision flag, we need to do the test on this one as well. So in here, we would do, something like that. So we're going to say, look, we want to know whether it's a sphere or not, right? And if we know that the test entity is a sphere, then we'll just do a thing like, look, if it's a sphere and a rectangle intersects sphere, or if it's not a sphere and rectangles intersect, right? Something like this. Make sense? It's pretty straightforward. So, seems good. And the same would be true in the top one. It's just going to be just a little bit different, but almost the exact same thing. So in here we would say, look, if the thing we're testing against is a sphere, then it's spheres intersect. Otherwise, it's rectangle intersects sphere. Right? And in this case, we have to flip these. You have to pardon. 4Coder, I don't know if anyone's ever going to fix the indentation in 4Coder. Someone tell me if they ever fix it so I can switch to a new version. It's been broken for like ever. So yeah, anyway, you can see here, this is just reversed. So, we have rectangle intersects sphere. In this case, the mover is the rectangle and the sphere is the person who we're testing against. And then in here, the opposite's true. So if it's not a sphere, that means, well, we were the sphere, right? So mover rect goes in the sphere slot, and off we go. That's really all we need to do to add the spherical collision, but we have the issue here of I just thought of something interesting I hadn't really thought of before. Oh boy. You know what? We don't need to do this. I kind of just realized we don't actually need to do this. So, because we know that we're always doing spheres or rectangles, right? We should actually be able to do this way more efficiently. We should be able to do this without actually doing any additional branches, right? Because what should happen is we should be able to say something like, if shapes collide, like mover is sphere and the mover rect, and then test is sphere and the test rect. Right? And we should be able to compute the answer as to whether these two things collide. I think we can just do it as one series of relatively concise operations, and then we just use the Booleans to merge those together into the answer, so that we only ever actually do one branch, which is if they collided, right? Right? Well, it's not branchless. Someone said that in the chat. It's not branchless because we still are doing a branch here. We could make this branchless if we wanted to, but it's unclear that you want to make this branchless because this only happens once in a great while. It only happens when two things collide, right? So the vast majority of the time, if you're doing this, you're probably not going to collide, right? Because most things are not colliding. But if I had all those ifs in there for the check, it would have to do branches. It would have unpredicted branches all the time, right? Because it would constantly be not knowing whether the thing is going to do this or that or this or that or this or that, right? So if shapes collide can be done branchless, right? And we let this be the branch here, that's just a better structure for this loop because that means that we don't branch on things that are very variable. And we do branch on something that actually matters, right? So I'm not trying to be branchless. I'm just making a certain section have no branches so that we don't have to worry, right? So we just want to do something like A is sphere, A rect, B is sphere, brect. Pretty straightforward. If left's code is better, isn't no code at all most best? Why are we even programming then? Okay, so let me just say one thing before I go any further. It is my absolute firm 100% non-ironic, non-sarcastic belief that actually most people programming today, if they just didn't program, we would have better software. Because most programming that happens today just makes things worse, as far as I can tell. Like, it doesn't actually make things better. So actually, ABC Derek, I agree with your what was probably a joke comment is actually true. Like, the vast majority of programming that happens today, the world would probably just be better off if it didn't happen. You know? So yes. Like, another way to say it would be go watch Glengarry, Glen Ross, and when Al Pacino says, choose out Kevin Spacey for making something up, right? And somebody, I want to say it's, is it Jack Lemmon who says, if you're going to make something up, be sure it helps, right? That's I think where I'm at with this is, like, if you're going to type in code, make sure it's actually helping. You know what I'm saying? Like, make sure what you shipped was actually better than what was there before it. And if it's not, just delete it. I want to watch that movie again. I tried to watch it the other day. It's not available on anything. The Blu-ray was like coming out at some point. I don't know if it came out yet. I want to like watch a good version of that movie. David Mamet. Anyway, it's a good play. It's a good play. The movie's good too. All right. So anyway, in Shapes Collide, we know we have rectangles intersect, and we can do that with A rect and B rect, right? And so in here, like I said, what I'm doing is very simple. I'm just doing a combination where the Boolean composite gives me the right result, and I'm just doing some extra math that I don't need to do, but that way, and I'm merging the results together, right? So what we would want to do is something like this. If we were just writing the whole thing out. But I don't actually, I'm pretty sure we don't actually need to do most of this. And this is the reason that I rolled all these together. If you take a look at what happens with a rectangles intersect routine, wrong one. Okay. So if you take a look at what happens with a rectangles intersect routine, it looks like this. Right? And maybe we'll do this, because that way it's exactly the same as the other routine. So this tells us whether the rects intersect. Right? And the other thing that we know is we have this closest point in box, right? So if you think about it, if you take a sphere and you want to know if two spheres are intersecting, it's really simple to do, because if the two center points of the spheres, which we know, if the two center points of the spheres are less than the combined radius, so radius of A, radius of B. If the two spheres get closer than that sum, then they're intersecting. Because spheres are directionally independent, like spheres are the same in all directions. And the only thing we have to say is like, well, we're getting an input as a rectangle. We're just going to not allow ellipses, right? So we're just going to take the x and treat that as the radius. Well, half the x is the radius. And when people create these, they have to know, right? So that's fine. We could try to support ellipsoids, but I mean, it's a lot more work to support an ellipsoid. Yeah, it's definitely a lot more work to support an ellipsoid. We're gonna have to do like Lagrange multipliers and crap, I think. I'm pretty sure there's no way to support ellipsoidal collision without like doing a Lagrange multiplier, like frickin' quadratic equation solve thing. We could do it, like we could definitely do it, but it's gonna be way harder. So because no one cares about that in this game, you would never do that on purpose, right? So yeah, I wouldn't bother. But my point is just, we know if two spheres intersect by just looking at the difference of their centers, right? So we can do something like this, like center delta, right? And that's just going to be like if we have a center A and a center B, we could just say like, okay, we know what those two values are, and then we subtract them. Right? This value here, we can take the length squared of that and just see. So spheres, if the spheres intersect, it would mean that the length squared of the center delta, that separation is less than the radius. And there's no point in doing a square root here because we can just compare the squares together. So we might as well, right? So we can just say, okay, maybe like max x or get dim a, right? So these are pretty straightforward. This is just a, subtract and a multiply. Same here. This is, excuse me. Really for collision, if we want to improve this, and we might want to, what we'll want to do later if we actually care about the speed of this is we should probably store our collision as a center plus radius. Min-max for collision is probably not the best thing because we want to be able to handle rectangles and spheres. Min-max makes a ton of sense if all you're doing is just overlap testing like this because, you can see that it's pretty straightforward to do, but it doesn't make a lot of sense if you actually want spheres. So there's that. Anyway, so if you take a look at this, right, if you imagined we have a sphere. Then this would give us the closest point on A to the sphere of B if A is a box. This will give us the closest point on B, right? If B is a box to A. Again, this is 1, 2, really just 2 times 3, so 6 operations to find the closest point on the box. So producing the spheres, pretty straightforward. Producing the closest points, very straightforward. And so, like, a rect sphere, a rect B sphere, and B rect A sphere are pretty if we assume that A is a rectangle and B is a sphere, it's actually the exact same computation here, only with only with a different subtract on the inside, right? So this is just like center B minus closest A. So you can see that the actual amount of work, and we had like, I haven't even looked at what this actually computes. It's entirely possible that now we could fold these down into a lot more ops. I'll put a to-do up here. But you can kind of see where I was going with this. If you... Can someone please tell me if the new forecoder fixes the indentation? I really, really want that. It's super annoying. Anyway, so we can probably fold down some of these operations quite simply as well, and we just have to analyze these. We don't have to do that right now because we really don't care, but you can see why I wanted to build these into one routine. There's so little computation here that I feel like I can not only share computations between things pretty easily, because like, especially if we don't store the centers. If we store the centers, you know, you can sort, but these are things we're going to want for all the different routines except for box. So like folding all those down to a simple set of things with no branches, I feel like we can get this down to a very tight routine that just tells us whether these collide, no matter what they are. And then for our results, we just and a bunch of stuff together, right? So for the result, it's just a bunch of binary crap. So if like A is sphere and B is sphere, and spheres, that's a collide. And then all we do is just have a bunch of these. Right? I'm just going to let forecoder indent this wrong at this point. There's nothing I can do about it. It just wants to indent everything wrong. So A is sphere, B is sphere, and spheres. If A is sphere and B is not a sphere, then we just look at A rect sphere. I'm sorry, B rect A sphere. If A is not a sphere and B is a sphere, then we do A rect B sphere. And finally, we just do if neither of these things is a sphere, then we're done, right? So we just smoosh, right? We're just smoosh. And that's it. So yeah. There you go. I think that's the entire routine. So that allows us to do shape collisions either way. And again, the only reason to do this is just to allow people to move diagonally around corners. A box can't move diagonally around corners, right? The motion of a box around a corner is strictly like a right angle. So, if it's going around a corner, it has to first go clear the corner laterally and then go past the corner, right? And so the reason for spheres is just because it allows you to say, like, look, if you hit anywhere on the left half side, if the corner's on the right side, then the sphere can glide around by moving in a curve diagonally around, and that's what we want it to feel more like. We don't want you to have to clear the entire corner. We want to just kind of roll off the corner. So the idea behind this is just to provide a different ways of having the collision feel. This is strictly for feel, right? That's what it is. So that the game like makes itself. I guess now I'm done with this, so I can actually align it properly, and 4Coder won't hopefully realign it for me. So I think that's it. Barring bugs in here, I think that does everything we need. So from then on, all we do is we just say, look, shapes collide, and here's our sphere information. I don't actually think we need anything else. There's entity flags. Here, we just need to add the one for the sphere. And in theory, this won't do anything, hopefully. It should just do its regular thing. What is the problem? Test entity is not known. Oh. There you go. So in theory, this should do nothing because nobody should have spherical collision set. So when we run it, we should just have... it should just do exactly what it did before, right? Everyone should collide as a rectangle, and off we go. If I change it to sphere... so when we do the glove, which I don't actually remember, where that is. Where do we create the glove? Is it in here? It's in world mode. So it was this one. I guess, yeah. All right. Right, because you don't create them at gen time. You create them when a player enters the game because you can have multiple players and stuff. Yeah. Makes sense. Not dumb. All right, so glove, right, we create this thing. The flags. Where did it go? So the flags here, we just want to OR this in so that it will, know that it's supposed to be a sphere. And the problem we're going to have now, like, obviously we want to debug this, but also we don't know, we can't see it is a problem, right? So we have no idea whether that got set correctly. We have no way of seeing it. It certainly doesn't seem like it did anything there. So there's that. But we don't even know if it's... we don't even know if it's correctly set because we don't have any way to draw it, right? Like I said, we don't draw actual spheres there or anything like that. And so when we look at this thing, we're just like, I don't know, like maybe it's a sphere, maybe it's not. So at the very least, I'll do the simplest thing I can, which is I will just draw a different color for spherical colliders just so we know, like, roughly, like blue will be for the regular rectangle colliders and red will be spheres or something, right? So nothing particularly fancy, but just in here, right, where we're picking the color, I'll do like a if entity flags and entity flag sphere, we'll just change to being a different color. And so, that way I can just verify that, it is what I think it is, and then we can move on to debugging from there. So there you go. So at least now we can see, like, okay, that's supposed to be a sphere. We know roughly what, like, I can't draw the sphere because you don't have sphere drawing, and I don't really want to add it because it's never going to appear in the game. It would just be for debug. We know the sphere is the thing that fits inside this cube, right? The radius is as long as that. So, we know what it's supposed to do, what it's supposed to look like. And so we should be able to just debug it from there. I will say it's hard to say exactly what's going on there. I mean, that... The problem with that is, yeah, like it's gonna be hard to kind of know, like, is that correct or isn't it, right? Like this is where we're probably gonna need, like, forget spheres, we're gonna need like pretty good diagramming to like figure out the collision points and stuff like that. So we'll see. But point being, at least we know that that is correct in terms of getting the glove set to a spherical collision volume. So let's take a look at these routines now and decide what we want to do testing-wise going forwards. So with our collides at P here, this is all pretty straightforward, and you can see like mover is sphere, mover rect, test is sphere, test rect. We're just passing in basically the flag and. So we're just looking at the test is sphere and mover is sphere. We're just looking at those two and passing them into shapes collide. And like I said, shapes collide is pretty straightforward. So you can see that we OR together collision stuff, and basically the first part of the collision is just these are the mask values. So like if A is sphere, B is sphere, we're going to run the sphere collection routine. We're going to run the sphere collision detector. A not B, then we do B rect A sphere, right? Not A B, we do A rect B sphere, and if they're neither of them spheres, then we use the rectangle, right? Now, we assume the rectangle part is correct because that's what we were using. We should probably look at this more carefully to make sure that it actually is correct, but, that one is not really what we would implicate right now. We assume that this is not implicated because we know that we're never going to use it, right? Because both of these are not going to be true. So we're really talking about these two cases: A sphere, not B sphere, not A sphere, B sphere. Those are the two cases. We don't know which one we're looking at the moment. Well, I guess we kind of do because we always pass the mover first. So in this case, we know specifically that we're going to be doing A sphere, not B sphere. So this is the case that we'd actually be looking at. This one right here. So B rect A sphere is what we would be interested in. And you can kind of see here that we look, all right, so what's the square of the radius of A? And, I wouldn't have a lot of concern that would be wrong. It's a very simple computation, right? It's just saying what's the x dimension, and we're going to take half of that because the diameter would be the dimension and the diameter are the same. So the radius is going to be half that, right? So that seems pretty straightforward. This here is just looking at how far you have to go to reach the closest point. So we're saying the center of A, which is the center of the sphere, and the closest point on the rectangle. Like how far apart are they, right? And again, this fairly straightforward. So as a collision check, that seems pretty clean to me because all we're asking is if we took the closest point that we could find to the sphere's center, if that is more than the radius away, then we're obviously not colliding because the sphere is only the radius long, so it would never reach the closest point. If it's less than the closest point, well, then it's obviously intersecting, right? So it's a pretty simple algorithm I chose there. So looking at this, we don't use closest A. We do use closest B. And closest B says, all right, whatever the minimum is, well, I guess we start on the inside. Whatever the maximum is of the minimum of the box, so the min corner of the box, and the center of the sphere, right? So whichever one is less. Sorry, whichever one is greater. And the reason that we do that is we basically say, all right, the minimum corner of the box and the center of the sphere, we want to take whichever one is higher because we're basically trying to say, like, look, if the sphere was on the min side, so if it was less, if it was to the negative of the box, then we want to just pick the minimum corner, right? And we want to do that for all of the dimensions independently, which this will do. And that produces a particular point, right? And then we just take the minimum of the maximum and that point, which will do the same thing for the other side, and that will produce the closest point, right? So... excuse me. So I think that's all good. And that all looks pretty solid. So really what I would like to do here, what I'd like to do here is do some diagramming. And again, it's the hardest thing in Handmade Hero because we really haven't built out anything for it. But what I'd like to be able to do, ideally, is be able to move a little circle around, a little sphere around, and validate that as I touch it to the box, that they collide, and as I move it apart, that they don't, right? I'd like to be able to actually interactively do that. That's what I would normally do. Maybe I just have to build that. I don't know. It takes a while, right? But that's what I would like to see here because I want to know. I want to be able to like test visually because looking at it numerically, it's very hard to know if it's working correctly. I suppose I could do like some testing of this routine non-visually. I could write something that calls it kind of in a for loop with the sphere getting closer, and then while it's moving through, it would test it, It's just not as good, Visual tests for collision things are always better than like a unit test or something, because especially if they find a bug, it's very hard for you to like intuit what the bug is if you don't have a way to see it. So that's the thing. So yeah, that's the thing, and it would be nice, right? It would be nice if we could do it. So I guess what I'd say is, I have a little bit of visualization already, so maybe let me just see what I can do with what we've got, and see if I can improve it to the point where this would work better. I don't know. Yeah. So the other thing that's important to look at here is like this can be improved really dramatically as well. The unembed direction, we now have a lot more information about it. So for example, if two spheres are colliding, then the unembed direction is just the difference of their centers, right? Which we already know. Um, so like, and the same would be true here. So these values for rectangle stuff, we still aren't actually computing that separation. We could change this to be doing it based off of centers, and then I do think we could compute it much more straightforward. What that separation direction should actually be. But for everything else, so for the rest of these, we do know what it is, right? And it's slightly better than this. So in this case, this is true. This is correct for spheres because it's going to be the same as this, right? It's the same value. But for non-spheres, this is an improvement because it looks for what the closest point is on the box and then uses the center point of the sphere. That's going to be the direction that you could move the sphere out most quickly. So that's the easiest way to move out of there. And so this could be improved by just having it be that, right? So that's another place where that could be done better. And so we should probably do that too. At some point. So yeah. Something to think about. Anyway. So yeah. So looking at this, when we draw the collides at P stuff, you can kind of see like when we like when we look at this stuff, there's so many things we'd really like to draw more. I'm just really torn about what to do here because it's always an issue on Handmade Hero because it's like I try to do stuff sort of like what you do if you were actually programming for real, but the reality is we can't actually really do that because it would just take too long. Because engine work takes a long time, and normally you have 8 hours a day to do it, and you definitely don't have 8 hours a day to do it on the stream. The amount of hours we've spent on Handmade Hero so far is like so tiny compared to the amount of hours you spend on making a game engine. That like we haven't even gotten. It's been like 5 years of Handmade Hero, but it's only added up to less than a year's worth of actual work if you were to lay it out on an actual work calendar. So the problem is I always have this problem of like, well, obviously the right thing to do here is to make a little app so we can look at this, so we can just visualize it properly and watch really carefully each individual step because there's almost certainly bugs in here and we just don't know what they are. And there's no real way to analyze it other than visually because the only definition for the correct answer for motion like this is that it visually does what we think it should, right? There's no like rigorous mathematical definition that we can apply to this motion stuff, right? It's just like it should generally allow things to move in a way that makes sense, right? So So I guess what I'm going to do, because I don't know what else I should do here, is I guess I'm just going to try to instrument this. I really don't know what else to do. I think that's probably the most straightforward thing I can do. Is actually try to instrument it, and yeah, like I really just don't know what else. So the way that I'm gonna instrument it is just pretty straightforward. Like I'm just gonna go like, all right, let's make a part here that's like if collision instrument collision or whatever. So there's just going to be like a giant chunk of code that comes in here, and we just say, okay, so if A is sphere and B is sphere, well, and more specifically, I guess I could just say something like this, right? And I can draw the box and the sphere. I can draw the actual separation between them and look. Again, I kind of feel like we should change this rectangle definition, the way that we're doing this, because if you look at how it works, it wouldn't be hard to just look at, because the way that we're doing the rest of these is basically just looking at the separation, right? We're just going like, look, how far away are these two things? If they're further away than their size, right, then they're not intersecting, right? I mean, it's not rocket science. This one is not. This one is like a direct overlap test. But if you imagined doing it differently, you could say something like, the center delta x, if that is if that's less than the dim, like So something like this. So you basically say, like, look, there's the radius. Everyone who was using the radius before now uses like just a part of the radius, because for spheres we're not consider ellipsoids. But in this case, then we just say, look, and in fact we could do this. And so in that case, we would just say, okay, we've got the total radius, and then we've got radius A and B. And so I think it's this, right? Like, if the separation of these things in any particular axis is less than the combined length in that axis, then, the combined radius in that axis, then you collide, right? And so if you look at that, it then looks the same as like these, right? We've done them all now in terms of some kind of a separation between the two. And they just start smushing like closer together, right? You know what I'm saying? And I think we can do that, right? I think we can do this, and we just get rid of this. And I think that would work, right? Let me just prove to myself that it sort of does. But it's like, if we're going to start testing this routine, I want to actually test it, right? So I like moving this glove around crazy like that. It's like the spring gets, because it's just a crappy spring thing, it doesn't have any intelligence in it. It gets super wound up, and then it can go super fast because we don't have any caps on it, right? Looks like that's broken. So no. What did I do wrong here? Oh, duh. Just the wrong. Sorry about that. It has to be touching in all. It has to be overlapping in all three. I don't know why. Yeah. Sorry about that. My bad. So yeah, anyway, point being, I'm going to smush these down into a more compact routine, and then I'm going to try to visualize it as best I can. And we'll just go with that for now, because yeah, making like an entire like test thing, which is what I would like to do, is probably not super feasible. Looks like that's still broken somehow. I feel like that's correct though, right? Like, the rectangles intersect if the center delta is less than the radius in each direction. Oh. Nope, still screwing up. These are signed. Right? So we can do it that way, and that's fine. But I think I probably wouldn't. I think what I'd probably do is this. Right? Again, because I'm just trying to keep this all looking roughly the same. Because I want to smush it down. Right? I want to keep smooshing. As it were. So rather than absolute value, I'm just going to square them, which is the same as absolute value for our purposes, because it will ensure that they're always positive, and we're only doing a comparison. So if we square both sides, the comparison will still hold. Right? And it will get rid of the negatives. Saltbean! Hello! Oh, who's the puss? Who's the ultimate programming puss? Do you want to enter some code? Do you want to put some code in? Yeah, you do. Okay. Okay. Do you want to talk to the chat? Do you want to read the chat? Chat always likes it when you show up. Well, some of the chat does. Anyway, the cat people. Puss, 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 puss. Big tummy kiss. All right. I don't know what the puss is up to at the moment. She may just be hanging out, or she may be mousing around. I don't know. So we'll see. What do you want to do, puss? What are you up to? Do you want to sit? Do you want to sit in my lap? Do you want to? Are you mousing around, or are you just hanging out? I don't know what you're doing. What are you doing? What are you doing? What do you think? You got any opinions on it? Okay. All right. Well, while the puss is pussing around, I'm gonna go hop over here and just play with this a little and see if that fixed the the stupid thing I did with the rectangles. Yeah, looks like it's fine now. Although it may not be colliding properly. Let's double check. No, it does. Looks good. Yep. So now we're really close. Come on, puss. Come on up. Okay. Okay. That's a good puss. So now we're really close in terms of how these things are getting computed, right? You can see that these are like getting to be very sort of similar sorts of computations, which is what I wanted. And I feel like there might be a way to just kind of simplify this down more as we go. We don't have to do it right now, but I wanted them to all look like that because you can see that there's like a pattern emerging, right? Where there's like, you square both sides of the thing, and you do a less than comparison, so that's always the same. And the only difference, right, is whether you sum the squares or whether you don't, right? Is mostly what's going on. And the other side is basically always the same. The only difference is whether you smush X out to all of them or leave it the same. So I don't know to what okay, the puss is scrolling the mouse now. What are you doing, puss? Are you trying to adjust the view? What are you doing? What are you doing? What are you doing? What are you doing? Huh? What are you up to? What are you up to? What are you doing? What are you doing? This is how puss program. They program facing away from the monitor, apparently. How do you even know what the code says if you're not facing the monitor? How do you even know? You don't, do you? You're just winging it. You're just winging it. You're just winging it. All right. So I don't think we need to go any further with that. Like, I'm fine with leaving this long form for now, but like I said, I just kind of wanted to get that into a, roughly identical comparisons so that we could sort of see what's going on, so that it would, so it would be easy for us to see later on, like, how this is going to smush down further. Because we can eliminate a lot of redundant terms eventually, compute just a few things once. The compiler already, hopefully, will be able to do a bunch of that for us because a lot of these are the same computation, right? But we can probably help it out by simplifying things down past where they are. Whereas the other one that was in there for rectangles looks nothing like any of these. The other thing you can see is this gets us ready, like, we can just start storing this. Like, all of these computations should probably go away because we can just make center radius be the thing that we actually pass in, right? So we can just make those be what we store for collision volumes because we don't really need rectangle. Min and max isn't as useful anymore. Now, that may not be entirely true because we have to look and see how this will go. It may be that min and max actually do still need to be there, in which case it doesn't matter as much. But we'll see. Okay, so puss. So we have an answer. Puss has sat on the mouse pad. So as long as we don't really want to use the mouse particularly much, we should be fine. But that's what the puss hath decided. We need a good cat, like right here. I need to buy a cat friendly sort of tower, like one of those things that would go like right here, so that the puss can stay like aware of the entire situation and oversee the programming, the entire thing if she wants to, and I can still type, right? So anyway, okay. So I don't really know about that part because I haven't ever tried a routine like this before. I probably the only time I program 3D much anymore at all is on Handmade Hero. I used to program 3D all the time, and so I would have thought about things like this a lot more. Nowadays, I hardly ever think about 3D. I just don't do 3D programming much anymore, even though that's all I did for like many years. So I haven't ever looked and said, okay, now that we care about reducing branches, which we didn't used to in the old days, now that we care about reducing branches, can you make a single routine that does rectangle versus rectangle, rectangle versus sphere, and sphere versus sphere all in one with a very limited number of ops? My suspicion is yes, we can do it, and it's looking pretty good already. It's just not our priority at all. So anyway, what I want to do is find some ways to draw this stuff a little bit better here. And so what I might do is say, well, let's draw a couple things if we can. So let's just pretend that we have some kind of a diagramming system. And I'll just say, like, all right, if A is a sphere, then I'll do a, like, we'll just put some diagramming stuff in here, right? So if A is a sphere, we're going to draw a sphere, and it'll be center A, radius A, and we'll do the same thing, for this. And what we would do here probably is say, like, some kind of garbage like this, right? You know what I'm saying? You can probably do this these days, I think. Couldn't do that in the old days, but nowadays most compilers have this. It was like only GCC had that for a long time, but almost everyone has it now. You know what I'm saying? So if we assume we do something like this, where you just imagine, this is Snuffleupagus-oriented programming here. I'm just imagining that I magically had a diagramming system. What would I do, right? Like, what would that diagram system have in it? Like, how would I use it, right? And it would be something like this, where I would just say, okay, here's me drawing the various pieces. If I have a sphere, then what I want to do now is say, well, even if I don't, so now what I want to do is look at the separation between these. And I don't know, like, maybe I want to do, like, maybe I want to do the testing here and actually draw a different thing in each case. I mean, I could, right? Maybe I want to do this. So if we have two spheres, we would draw both spheres, and something like that. We would then do, like, diagram, like, the separation between them, which would be like that. I don't know. So I might actually say something like this. And the line that connects the two, I would want to do like, just so we can see. I don't know that we have anything else we're computing here, because that's basically it, right? So there's really not much to draw here, right? But there you go. And so what we need to do is some kind of like a condition like this. So we would just say, look, there's a result that comes out here. And we would say like, yeah, the result is that they collided or whatever, right? So it's a true, this is a true or a false, so we want to be able to see that. You know what I mean? So something like that. And, maybe we would say like collides, and then the result would say like yes or no, right? So something like that. So if I imagine I had the system, it would look something like this. And then, for the other ones here, I guess I would say we've got the not case. So, for those two, and those would just draw boxes instead. I think we want this probably in all cases, right? And so then the interesting cases are here. So in this case where we've got two different ones, then we have to kind of do like, okay, we've got A as a sphere and B as a box. Or the other way around. Right? And then in here we would do, we need this stuff. So in this particular case where we have a diagram point, we want to draw the closest point on A. Sorry, the closest point for A. The closest point on A to B. So in this particular case, if A is the sphere, then it's the closest point on B that we would draw, right? And so I guess I lied. We don't actually want this. This is only in the sphere case, and then in these cases, it's the other way around. So we would have the closest point on B drawn to A, right? So that's the actual separating it. We probably don't need that. And then the opposite would be true in this one. So we draw the closest point on A out to the sphere's center, which is B, just so we can see like where that would go, right? So I think that's it. I don't know that there's anything else that we would need there, right? So we'd basically just have a diagram here that does like a begin and an end, and it, that would be it. And we would have maybe diagram ends. I don't know. We probably want to have multiple ways of doing results there. But anyway, we'd have some way to like dump these diagrams out. and off we would go, right? So when we are calling these, we would call it, it would be called lots of times. So it gets called from in here at this collides at P thing for each entity. And I don't know. I would guess we would probably want something like this in there. So if you look at what happens in here, right, we've got move entity, and there's like a bunch of different phases that kind of happen here, right? And so in here, this is like the voxel phase. So when we're drawing those diagrams for collides at P, that's going to be all of those calls in there are going to be for doing the voxel, right? And we can. I don't know how far we want to go with this, but we can do it, more specific than this. But basically, we'd have the phase would tell you like, oh, we're doing collision voxel or we're doing refinement, right? And that way, when we step through it with the diagramming, we would know which one we had, and that'd be it. Now, then we would have a handmade, diagram. This must be something that Ryan put in there, because I don't. Yeah, I bet that was it. Because I'm like, I never do that. Okay. I don't care about that. Anyway, so we'd have a handmade diagram here, which would accept these commands. So you'd have, just whatever the heck I said we have. So you put like names in there or crap like that. You can draw spheres, so they would have like a center and a radius. And we just assume that the name is nothing for now. And then we got the box. And this result thing, which I guess I should probably make it symmetric. And that's it. Right. So if I go back to handmade.h and, after we kind of get this crap in there, I'm assuming that, it would be sufficient to put it like here in terms of include order. And, that's fine. And so then if we compile it, I need to actually have handmade diagram.cpp here, even though nothing actually happens. Yeah. And so then I can make this compile and leave it this way for next time to have these be implemented, right? And oh wait, we do internal here. I changed to using function instead of internal, so that way it's the same as JavaScript. I thought that was kind of handy because I was like, oh, now whatever parser you write to identify functions will work on my C code and my JavaScript code. How clever, right? It's not that clever, but since I always put something before it, I was like, oh, why don't I put something that actually works the same as some other language? And off you go. Okay. These should have defaults as well. So if you don't care, you don't have to have those things specified. All right. And that's it for today. I guess next time we'll add some of that, and off we go. Yeah. Where is... Shouldn't that have given an error? How did that... Oh, duh. Maybe what I'll do here is... that. You know? I don't know. I was like, how did that compile? It compiled because it was if zeroed out. That's why. So it never actually got compiled. All right. Any questions? Oh, so ForCoder 4.1.8 does fix indentation. We have to do that. We have to update. Oh, I can explain why I typed const. So one of the things I was doing for Star Code Galaxy is I try as hard as I can to not force people to turn off a bunch of warnings on the compiler for the beginner code, right? And so I'm now used to the stupid... It really aggravates me, like, deeply. But the default in C++, because the people who design it are the worst people in the world, they default strings to constant. So if you want to accept a string literal, it has to be char const star, right? Which is the dumbest idea. It is so stupid, I cannot even begin to describe just how dumb it is. It is extraordinarily stupid. But that is how it is. So I reflexively now sometimes type char const star if I don't remember whether I'm in my code base or the Star Code Galaxy code base, because that's the one place it forces you to use const. You don't get a choice. You would have to disable warnings to do anything else. I mean, unless you want to type this all the time. Right? So yeah, I mean, what can I say? C++, horrible language designed by people who have no idea what they're doing. I've said it a million times. I'll say it a million more times. It's horrible. That's just one example of just how stupid it is. It's like, guess what, folks? If I wanted my strings to be constant, I'll tell you. You know? I'm the programmer, not you. If I wanted my string to be constant, I would tell you that it was constant. Why is a new diagram system needed? Why not just use the existing renderer? So we will use the existing renderer. We're not going to write a new renderer. The diagram stuff is just there because this gets called like hundreds of times a frame. So I can't, like what you saw, I mean, it already has a little bit of drawing in there, right? If I take a look at what's going on, you can see it drawing a bunch of stuff, right? So you can see it drawing, but we don't really have any constructive way to actually look at that information. It's just some overlapping cubes, and I can sort of tell, like, okay, so it sort of started there and it like tried to get over there, I guess. But if I try to actually put, like, imagine each one of these corners had collision testing done on it, right? So how the heck am I ever going to actually look at this information constructively if I add anything more to it? And so the diagramming stuff will not use a different renderer. All it's going to do is I'm going to have a little panel so I can step through the diagram and show like one at a time, right? So that's all I need. I just need something I can dump a bunch of like line box directives into, and then it will only output some restricted subset of that to the actual renderer so that I can actually look at them. That's all it's going to do. It will call the existing renderer. Off topic. Should the push array for spatial grid leaves in handmade lighting.cpp be aligned to 16 bytes for move APS on 128-bit memory operands? I don't remember, but let me look. So you're talking about this one? Right here? So I guess my only question is, are you So is the problem that you're seeing, I mean, assuming you're seeing a problem, is the problem you're seeing that the compiler is generating a move APS? So my preferred solution to that would actually just be to not have the compiler produce a move APS, because there's no reason to produce a move APS. But obviously, if your compiler is doing that, then it is. So, yeah, you can certainly fix it by passing the alignment value here, right? So, if you want to, you can do that. This doesn't need to be cleared, right? Oh. Why do we clear it that way? Here. That's fine, right? So you should be able to do that, and there shouldn't be any problem with that. Like, it should just work. But ideally the compiler would not think that was aligned because we never told it was aligned. So I'm not sure why it thinks it's aligned in the first place. So, but I'm happy to, I mean, it's no skin off our back at all to align that, so that's totally fine. So, like, I'll just put a note, like, so, like, that's totally fine. Because, again, aligning to 16 here doesn't cost us anything. It's basically free. It's not like aligning a structure or something where we're losing actual memory and cache bandwidth by adding it. Here, this is a giant array. Like, it's a huge allocation of crap all packed together. So aligning the base to 16 is fine. My only question is lighting spatial grid leaf, I assume that's aligned already? Yeah, it is, because 4 wide. So I was like, so that's also has to be aligned, but I was assuming it already was, and it is. So that's totally fine. Are we planning on having cylinder or capsule collisions? No, I don't think we need those for anything. Those spheres should be sufficient for our purposes. I don't think I ever said we would add cylinders or capsules. I was just pointing out that those were things that people used. But we don't have a use for those. Should id.value be checked to be not null in handmade asset? I guess my question there is where specifically? Where are you talking about? Which part of it? Load font. Okay. I'm assuming this is the appropriate load font. What the heck is this? Oh, asset builder. Yeah, we don't care about that. I mean, I would say sure. I don't know that we ever actually use that. So, you know. But in general, we allow that for other things. So, you know, there's no reason we can't allow it here. You know, most of our stuff does do that, right? So we certainly could, right? Like, that'd be totally fine. I don't think anyone does that, so I don't know that it actually matters whether you do that or not. But if you just wanted to support it, I mean, there's no reason you can't. Let's see where this is called. I mean, the thing is, like, it's kind of just redundant because you look, they're guarded. The font stuff is guarded already. So I don't know that you can actually ever get that situation. to occur. So I don't know how you were ever having that actually happen, but yeah, anyway, point being, again, much like the Align 16 one, it can't really hurt. That function isn't called super often or anything, so, and the check would almost always be completely predictable anyway, so it's free, so there's no point in not checking it, right? First time catching your stream live after finally catching up with every Handmade Hero episode. Wow, all right, that's dedication. Really fun and enlightening file along, super looking forward to SGG as well. All right, awesome. For the upgrade to 418, it seems to break something with modal bindings. Oh. Well, that's unfortunate. I guess I can't upgrade then. Alright. I don't know what's going on. I just hope somebody fixes something soon. So somebody let me know when we can re-switch or whatever. Could you explain the flood fill algorithm as it was used in the Minesweeper game? I mean, no, because I actually don't really know what you're talking about. What kind of flood fill? Do you just mean talking about if you have a series of cells and you say fill all of the cells connected to this cell, like that kind of thing? The fix for auto indentation is one line. You could apply it to your current forecoder. Okay, maybe we can try and do that then. Any reason you only have the XYZ diagonal case in the voxel collision system? Wouldn't you want XY, XZ, and YZ diagonal motion as well? Yeah, I mean, I guess I don't know. You may be right. It's entirely possible. It's entirely possible that we should just have a few more of these, right? I mean, it's also entirely possible that we shouldn't do this one. I don't know, right? I'll put a to-do in there. Hard to say. Does Handmade Hero really not have a sphere drawing tree? Yeah, I mean, we've never done any sphere drawing at all. We did do one time, we did something different, which was we're trying to distribute points on a sphere, and we drew the points. So like there was a thing that looked kind of like a sphere, but we've never drawn a sphere in Handmade Hero. We don't have any spheres. This is the first time there's ever been anything spherical in Handmade Hero, because everything's either a flat plane or a box, right? So we've never had to draw a sphere. It's not hard to draw a sphere. The reason that it's kind of a pain in the butt to add currently is that our renderer only draws cubes and planes. It really only draws planes, right? So drawing a sphere is something that's pretty easy if you have a general purpose renderer, but ours is literally just a little sprite renderer. That's all it does, right? So couldn't you just apply a circle to a camera-facing quad to fake a sphere? We could. I mean, I'm not worried about it. Like, I'll just draw whatever. I can just draw some, like, a little cross or something. Like, I don't care, because we don't have to actually draw a sphere, so it's not a problem. It's just, yeah, it's not something we ever did. This algorithm and wiki flood fill. Okay. I guess, what do you want me to explain? I'm not entirely certain what you want me to explain. I mean, this is a pretty complete explanation, right? How does it work? Well, I mean, so the thing to think about here is there's lots of different ways you might implement flood filling, but it's pretty straightforward to understand it, right? Which is just that every time you have a particular you can just think of it as any connected graph. So anything where you have like a cell here, you can imagine a connected graph is each cell is connected to each of its neighbors. So every cell has 4 connections to the top, bottom, left, and right. You know what I mean? Any connected graph, a flood fill is just take the node that you are on, add each of the nodes that are connected to that one to your thing to consider, right? Fill the current one, and then move one down the stack, right? That's it. You just keep going. And that's a graph filling algorithm, and it fills graphs. No matter what the graph is, doesn't matter if it's pixels or otherwise, right? That's it. So they're always, they just keep a stack, and they just say the first thing you put on the stack is the starting point. You pop it off the stack, consider it, find its neighbors, add them to the stack if they're connected, right? And in this case, connected means empty. Like, you don't want to go into things that are filled, so the edge would just be, right? And that's it. It's just a simple walk, right? So, I mean, I can explain it in more detail if there's something else that you want to know, but there's not much else to it than that. You can see why, like in here, there's talking about how, like, a simple recursive algorithm doesn't work very well. The reason for that is because there's so many pixels, if you're doing like a pixel fill, that you blow out the stack space for your program if you are basically using recursion as your stack. but, you know. So, all right. But someday, if people really want to know more about flood fill, if you're really like confused about flood fill, we can talk about it more in detail some other time, maybe during a pre-stream or whatever. But there's really nothing to it. It's literally just, if you imagine you just have a graph, any graph. So if you want to flood fill pixels or Minesweeper, your graph is just each cell is a node and it's connected to 4 other cells, which are the nodes inside of it. And you just imagine the edge connections are just it's connected if the cell is empty, and it's not connected if it's filled, right? And then you just do a simple walk. You just say push all of the neighbors on, and then go to the next one. What? So Cyberpunk 2077. What is the status of that game? Does anyone know? Because it sort of came out, but it's not, doesn't really work, you know? So like, did they have any kind of like announcement as to what happened with that game? Is it gonna be like updated or anything? Because it got taken off of PlayStation. Like, it's gone. So it's not really out in the sense that there's some stores that still don't even allow it because it was so unfinished or whatever, right? So I don't know what to make of that. But all right. Anyway, thanks everyone for joining me for this episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org, and it comes with source code so you can play around with it. I'll be back here next week. We'll put in some diagramming and we can start doing some testing, see if there's bugs in the collision that we need to fix. Until then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.